Rust can be prevented if we paint the areas exposed to oxygen and moisture. This is done on many bicycles and cars. Another method to prevent rust is by placing a layer of oil or grease. This is done on many bicycle chains. It helps lubricate the moving parts, which reduces friction and slows down the rusting process. Another way to prevent rusting is a sacrificial protection method called galvanizing. Have a look at this reactivity table. Zinc is more reactive than iron. When exposed to oxygen and moisture, zinc will corrode faster than iron. So if we put them together, zinc protects iron but is sacrificing itself, hence the term sacrificial protection. This method is applied to prevent rusting on ships. The oxidation of zinc can be described using this following equation. So besides preventing rusting, there is another advantage to this galvanizing process. The formed zinc oxide layer can be removed, and the freshly exposed zinc can corrode once again, thereby further protecting the iron or steel hull.
There she is, Lady Liberty, standing there in all of her blue-green glory. But she wasn't supposed to be this color. So how to explain Lady Liberty's color change? Simply, it all comes down to chemistry. During her first few decades in the Big Apple, the statue slowly turned from that shiny copper color to a dull brown, and then finally to the blue-green, or as they say back in France, verdigris that we see today. Anyway, her color change happened because of oxidation reactions between copper and the air. So let's get into it. Now, when an atom loses other elements too, the color change from coppery red to blue-green was bound to happen as soon as they parked her in New York Harbor. And here's why. First, there's all the oxygen in our atmosphere just hungry for electrons. Then you add all the elements in New York's polluted air into the mix and voila! In the first reaction, copper gives up electrons to oxygen. That creates this mineral, cuprite, which you can see is a pinkish red. Next, cuprite loses more electrons to more oxygen, forming blackish tannerite. The black color of this tannerite explains why the statue slowly got darker over the years. Now, let's pivot to sulfur reactions. Sulfur finds its way into the atmosphere through natural processes, including volcanic eruptions. But humans have also put a lot of it there too, with their boats and cars and pesky airplanes and factories. So when sulfur dioxide gets together with water, it forms sulfuric acid, which can form green stuff with copper oxides. Now, back to our color change. Lady Liberty gets painted with the sulfuric acid and her green color gets forming. Throw in some chloride from the sea spray around the statue's Ellis Island home and, well, you see what happens.